I will start from where we left. So first, I talk about the climate science and climate change, what exactly is the global warming. Then Professor Udit yesterday also introduced you to the climate change and the climate science, and then later on how actually we do the climate model. So today we will actually learn how we do that climate analysis. We will do the hands-on through Python. So tutorial to temperature and precipitation analysis. We will use the temperature data, we will use the precipitation data, and we will do some basic analysis on temperature and precipitation using the Python. So yeah, this is just my introduction. Okay. So my name is Danish Mansoor. I'm affiliated as SGS Lab first year student. So this is the content introduction to climate data. What exactly is the climate data? Different forms of climate data. There is temperature analysis, both historical and future data we have. We will do some daily temperature analysis, average annual temperature analysis, average monthly temperature analysis. Then same with the precipitation or rainfall data. The only thing is that is extra in the precipitation is this extreme rainfall analysis. We will see how the rainfall extremes are increasing over time. It's not only the average that is increasing, it's also the extremes that are increasing over time. So we will learn today for how these extremes are increasing over time. So please note this, it's very important. So we will have a quiz. It's no more surprise, but we will have a quiz. And it's 50 marks quiz. So please pay attention to the details of it. There will be surprise in the details of the quiz. Okay, if you have any question, raise your hands and I will be happy to answer your question. So let us start with the introduction of the data. So the climate data, you can see the climate data in the form of observational data, then model data. So in observational data, we have the weather stations, observation at oceans, satellites, radar, and LiDAR. In model, we have the reanalysis data, seasonal to decadal precipitation, predictions, and climate models. So this is what you were learning yesterday, how we can develop the climate model. And these are some of the basic variables in climate. There's air temperature, there's a wind speed and direction, there's a water vapor, pressure, precipitation data, surface radiation budget, discharge data, salinity, there's emission data, snow cover, and there's a soil moisture. So how many of you are aware of all these data sets? How many of you have done a bit of work with this kind of data sets? Raise your yes. Yeah.
Oh, like what kind of data?
Yes.
Like temperature data?
Yeah, use the temperature data.
Yeah.
Okay. For the US.
For what?
So what was your study?
Oh, sorry. I did a project using temperatures of the ocean.
Temperature of the ocean.
Yeah.
Wow. Any other? Yes.
Salinity,
Okay.
temperature, where people, like I mentioned just now, I did like a neurological study of a shelf off in the Northwest Atlantic.
Okay.
Yeah.
Any others? From the back, yes.
Yeah. Water temperature, pressure, salinity from conductivity. I think that's all.
So you have idea of how the climate is going to expand.
Yeah, it was for a slightly different project. Yeah.
Okay. Backside, anyone from the computer science? Okay. So these are the climatic variables that we use for different purposes. If we had to do some kind of atmospheric analysis, so these are some of the data sets we use: air temperature, wind speed, direction, water vapor, pressure, precipitation, surface radiation budget. So if someone is interested in oceanography, then he uses the sea surface temperature, sea surface salinity, sea level, sea state, sea ice. and many other variables. Okay, so it depends upon the objective of your study. For example, if someone wants to learn about the heat waves, now it depends upon whether he wants to learn about the past heat waves or he wants to know more about the future heat waves. So the data set depends upon what kind of analysis you are planning to do, what kind of a study you want to do. You want to do a study based on the past, then you will fall in this category. If you want to do some studies for the future, so you will be using the climate model. So it all depends upon your objective. What is your objective of your study? How many of you are planning to explore climate science in depth? Okay, what are your plans?
I'm interested in like, I don't know, like,
Just give the broader
like solar.
solar.
Yeah.
So that implies usually more than this one. Surface radiation, budget, air temperature,
Yes.
wind speed and direction. So these will be the major parameters for you if you are working on solar. Anyone else? This side? Yeah, no, I don't. Anyone else? A few hands. Yeah, no, I can't see anyone. Taylor, do you have any plans?
No plans, but yes.
Okay. Anyone else? Nathan?
Yeah, I'm the same way. I have no plans.
No plans? That's good. Sarah, you?
Not exactly on the science, but maybe something around the business side.
Okay, business side. Nice. So that implies that she will be done with the climate when you will come
Yeah.
to do the business. Okay, so now it depends upon the objective of our study. For example, if I have to study the heat waves, I want to see about the heat wave status of the heat wave so far across the world. Then I will focus more on the observational data, reanalysis data. So we will talk about what exactly means the reanalysis data and the observational data. But if I have to do some kind of study for the future, so then I have to focus on the climate model. Because climate models give me the data till by the end of the century. So that's enough data for me to analyze what's going to happen in the future. How heat waves or drought is going to change over the time under the climate change. Similarly, now some of us are also in the climate domain are working on this seasonal to sub-seasonal data sets. For example, if you do some kind of a study, how the monsoon is going to be here in Thailand. It doesn't come over these categories. Then you have to do this seasonal to sub-seasonal. And it's very important. People are using the machine learning, AI and all those things to handle these kind of seasonal to sub-seasonal changes of different climate variables. And please note that when we are talking about the climate, as yesterday Professor mentioned, it's a long term. So we generally take the climate of 30-year time period. When there are changes in the 30-year time period, then we say, okay, there will change in the climate. But daily variations comes over this one. It comes in the weather system. So there's a difference between the weather and the climate. So all of these components are up under the umbrella of observational data. So we have two different types of observational data. One is called direct. Measurements are taken and the instrument comes in direct contact with the variable data. For example, the weather station. So where is our weather station? So these are some weather stations. This is also the weather stations. This is also the weather station. Weather stations basically are very expensive. So if you go to the developing nations, you will not see much of the weather stations there. You will not see much of the observational data there. If you go to the African countries or any other poor countries, they don't have this kind of facility because these are very expensive. And the operational cost of these instruments are very, very high. So that's why if you are planning, let us say, LRE is planning to study on solar budget and all those things in, let us say, in Africa, she will not get all the data. But if she will plan to work for the United States, she will get all kind of data because the United States will have a good observational data, but the poor country doesn't have it. Not only that, we have the satellite data. The satellite data comes in this indirect data, where the system is not directly in contact with the climate evaluation. Similarly, we have aircraft, we have satellite images, geostationary satellites, and there's some other polar orbits as well. So these all come into observational data. So then, not only that, if we had to do the paleoclimatology, we have to study the past. Yesterday professor was showing you about the past, that okay, we have the carbon emission and temperature in the past as well high, right? So people do this kind of analysis to collect the data. So they collect the data from the tree rings and the ice cores to change in temperature and precipitation. And if we have to learn about the changes in ocean, we come with these corals. So it's very important to know about the oceanic temperature and sea level change in the past. So these are a couple of things that we use in paleoclimatology to understand the past climate. Just one question to all of you. Is paleoclimatology necessary to study? Why do we need to learn about the past? I don't know about the past. It doesn't impact me. Yes?
If we know how climate changed in the past, we can compare it to how it's changing now,
Okay.
the rate of change.
Any other thoughts? Why do we need to know about the past climate? You? Any idea? No? Yeah.
Well, like what we were saying, we should use what happened in the past by studying that to predict what could happen in the future.
Yeah. That's one of the major reasons to know about how the system will react. The climate system will react when we simulate all these changes that happen in the past. So in past we don't care about it because we were not there at that time. But now it is impacting us humans. So we want to know how these glaciers act when they will start melting. How the sea level will rise. To what extent the sea level will rise. So all these things are important to know. And all things come from the paleoclimate. Okay, then we have the model data. So basically the climate model is a numerical representation of the climate system based on the physical, chemical, and biological properties and the feedback associated with it. So in climate model, we represent everything in terms of equations. Yesterday you saw how we can use the equations to understand the basics of the climate change. We were doing yesterday the small equilibrium between the input radiation and output radiation. So that's a component, that's a part of this system model, climate model. They use the physical equation to understand the different processes. Then we have the reanalysis data. When you combine the observational data with your model data together, so we end up having the reanalysis data. So reanalysis data is important when we do not have enough observational data. But please note that we don't use reanalysis data for the future. It's only up to the present. If you tell me, let us say, Eva, right? If Eva will tell me, okay, I need a reanalysis data for next year. We don't have it. Because for reanalysis data to have, we need an observational data plus the model data. But I can tell her, okay, I don't have the reanalysis data, but I have the model data. I can give the model data. The model data is available. But reanalysis data is available too. Okay. Now let us come to the tutorial of it. So just a basic introduction of the climate data. Those different types of climate data. Make three major components of the climate data. One is the observational data, one is the model data, and the third one is the reanalysis data. Observational data has its own types. One is direct data, when the instrument is exposed to the variable, climate variable, and when the instrument is not exposed to the climate variable, then it's called the indirect data. So then we have the model data. It comes with the physical processes, physical equations. And when you run the physical equations for the entire globe in a 3D model, then you come with the model data. So then we have the reanalysis data. We combine the two model data and the reanalysis data together. Sorry, model data and the observation data together to get the reanalysis data. Now today we will learn about the temperature and the precipitation. Not only that, we will see if there is a difference between the urban area and the rural area, and non-urban area. How many of you are aware that the temperature in the urban area is higher as compared to the rural area? Oh, sorry. So that means you might be aware of heat island impact effect. Urban heat island. What does that mean? Arthur, any idea?
And maybe it's because people are so concentrated in one area.
Sorry?
Like, since people are so concentrated in one area, it produces.
Okay.
So the urban heat island effect is like concrete and like all those surfaces like absorb a lot of heat from the sun, and like green spaces, trees, like have like a cooling effect sort of. I don't remember that much about it. But.
Anyone else wants to further? Yes.
Buildings also will
Hold
trap.
on. Yeah.
I
think you raised your hand, right?
yeah.
Okay.
I think also like thinking about more urban areas with more like cars, vehicles, stuff like that contribute to a lot more pollution rather than in rural areas. You're not going to have as many vehicles that are contributing to that pollution.
Okay. Good. Anyone else? How many of you want to live in urban areas after you are done with the career? No, all of you. I want you to live in a suburban countryside.
Rural area?
After a career,
Sorry?
when are we moving?
After I'm done with my career.
Oh.
Not living, but of course. I'm like, go there.
Can we do the vote again?
Yes. Sorry?
Can we redo the vote?
Yeah.
We have the temperature data and the precipitation data. So what we have observed so far is that in urban areas, the temperature is 1 or 2 degrees more compared to the non-urban areas. It's all because of the urban infrastructure you have. The first thing is that you have a concrete. The concrete is a problem that it absorbs so much energy, it doesn't emit more during the winter, at the night time, during the night time. And another thing is that there's not enough circulation in a city, in the urban areas. So these are two major reasons why we observe that in urban areas the temperature is high compared to the non-urban areas. So we want to know whether the temperature is changing between the non-urban and non-urban areas. Similarly, the precipitation, what we have observed that in the urban areas there is an extreme rainfall events are observing more compared to the non-urban areas. So we want to know whether this is true or not. that's true. But we want to see whether we can capture those things in data or not. So what is the experiment? The experiment is that I will choose Thailand as a study area. I will select 2 grid locations, one as a Bangkok, considering as an urban area, and then I choose a ones along the countryside where there is a lot of green. So I took 2 time series, one from here, a representative of Bangkok, and one from here, representative of the rural area. So this is the temperature. So if you can see here, this blue line, this is what is the historical temperature, historical and the future both, from 1850 to 21. We see that in the urban area, the temperature is comparatively higher as compared to the non-urban area. And not only that, you can see this is the seasonality. I was talking about the seasonality, right? That we have the seasons. We have the high, we have the winter, we have the summer season. And just exactly you can observe here. See, the temperature goes up and then it comes down. And this is a repetitive pattern. But the problem with the climate change is that these seasons also change over the time. Like can you see the similar pattern? It's a repetitive pattern. But under the climate change, this repetitive pattern is not possible. That's going to change. Similarly, this is a non-urban area and this is the urban area. You can see the temperature difference in each season. So this is what is the problem with the urban and non-urban area. And that's why I don't want to live in urban area. So then it says this is not the rainfall analysis, this is actually the temperature. This is a heading error. So this is, I want to know, yes,
So why does it peak, the non-urban area peak higher?
why is the peak higher?
Like it goes above. It's,
It goes above.
yeah, in relative to the urban. At one point.
So you're saying is why is it that it goes
Yeah,
higher in
yeah.
certain regions?
There's more extremes and.
Yes, there are 2 reasons.
Yes, sir.
One is that, one is here, it's close to the tropics, it's close to the equator. And the second one I choose here. The more you go away from the equator, you will see more increase in the temperature. That's what I show you during my presentation. That in tropical areas, we will have a fairly around 27, 28 degrees Celsius throughout the year. But once you enter into the subtropical area, then the temperature goes 44 also. And the North India is the best example of that. You will see in the summer season it goes very high. You will never see, very rarely you will see in this area the temperature above 42. But in North India, let's say for example, as it comes under the subtropical zone, you will see the temperature will go easily 45, 46. And Rajasthan, one of the desert in India, the temperature goes easily higher. So this is basically the average annual temperature. I want to see what on average, how this temperature is increasing or decreasing over the years. So what I will do is that I have the daily data. For example, this is the daily data. For each year, I will now average that. So from the daily data, I have 365 days. I will take the average of that and I will get a single point. And that will be the representative of, let us say, 1880. Similarly, I will repeat that process for all the years. And that's how we can get this plot. That average annual temperature. Annual average temperature is very important for certain things. For example, in the dam operations, it's very important to know what is the temperature, on average the temperature is going to change, how it's going to change. And the average temperature gives the best representation of that rather than the daily temperature. So you can see easily here how the temperature, so this one, the solid line, this is the urban area. So coming back to Mehal's question, why are the peaks? Even though some peaks are here higher, it's a daily data, but if you look at from this level now, you can easily see that on average the urban areas are more warm as compared to the non-urban areas. And you can see, so this is the present, it's a historical data. And this is the future data. So we are taking one emission scenario. Yesterday Professor mentioned about the emission scenario. That if we have this kind of economy and this kind of emissions, RCP, different RCP. So this is one of the RCP. So you can expect that this you can expect in the future as well if we are going to emit the carbon emission the way we are emitting currently. Now, here's the question. What are your thoughts about the heat wave? Are the heat waves going to increase or decrease? What are your thoughts now? So this is the past and this is the future. Compared to the present, for the past, our heat wave is going to increase or decrease based on the temperature. Because we usually use the temperature data to define the heat wave. Temperature is the primary variable there. Now you can see here that the temperature is increasing over the time. So then we will be expecting more heat wave. Okay, we are going to expect more heat wave. Then what is what will be our response to that? So how many of you are aware of the cooling systems, public cooling systems in USA? In the United States, there are certain places, public places, where when the temperature goes high, they open those places for the common people. They will go there, spend a couple of hours there, and they will leave. And the homeless people even sometimes stay there when the temperature is high. So the government basically build those kind of structures across the nation for the places where they are very hot, so that the public can spend some time there and get rid of the heat waves. But that's not the case when it comes to the developing nation. Because they don't have that much of fun. They don't have that much. They have other priorities to do. And that's how those who are in the planning, urban planning people. So they do a lot of things with those. Okay, this is what is going to happen in the future. Then our urban infrastructure should be ready for these things. We should have more cooling systems. We should have more sustainable. We should have more, greenery inside a city. If you are going to develop a new city, we have to plant more trees across the city so that we can reduce this temperature. So this is the on an average. So, let us say if you want to know about the temperature in January, on an average. So this is the temperature in the January. So this is both urban and the non-urban area. Similarly, it's in May, right? So you will expect around 30 degree on an average you will expect the temperature throughout this entire. But it can go up to 32, 33, 32, sometimes 25. On an average, the May month has this amount, this kind of temperature. Similarly with the rainfall, we have the daily rainfall. Again, we can see the seasonality of the rainfall. There are certain months in a year where we receive a lot of rainfall. Certain months in a year when we do not receive much of the rainfall. See here. So these are the months where we do not receive more rainfall. In fact, but there are certain seasons. What's the seasonal, the rainy season at the Bangkok? We see a lot of these tourists during this period, November, December, January, February. One is that you cannot see the rainfall, and the second thing is that the temperature is also very good. So the humidity is less during this time because we are not receiving rainfall, the temperature is less, and the humidity is also less. Okay. So similarly, we have where is it? Yes, annual maximum. So this is the extreme precipitation. You can see here in the present, on a single day, you will receive around 20 mm of rainfall. And one of the best thing about it is that it's not changing much over time. We saw that the temperature is changing for this part. So there are trends. But when it comes to the extreme precipitation, it's not changing. So if someone is the urban planner, so now what will be his take away? So he will, or the urban planner will plan to design a city in a way which is more compatible to the temperature, and he can negotiate a bit here and there with the precipitation or the flood. Because that's what he can observe from the future. That I am going to receive more rain, kind of temperature is going to high in the future, hence I have to be much prepared for the temperature. But I'm not going to receive much of the extreme precipitation. Extreme precipitation basically causes the floods, major, especially over this area, South Asia. So, hence I can negotiate, I can play here and there to minimize the cost. So that my city is more robust towards the heat waves or temperature exchange as compared to the precipitation exchange. That's how we translate this here. We just do this analysis as a climate scientist. But then after that, the other, let's say, even the economics people who are dealing with the economics, they will also look into this one. This one. How the daily wagers, those who are working in the field, how it is going to impact them. Because then they have to change the weights and all those things. If a farmer will go outside, the farmer is the best example. If the farmers will go outside and work in the farms, then farming is very crop. Not only that, the temperature is the major source of evaporation, right? So for the dam operations, if the temperature is going to high, we are not seeing much changes in the precipitation. Much changes in the precipitation. That implies I have to design my dams accordingly. I need to know I'm going to receive a lot of this solar radiation. That implies more evaporation. So I need to design these dams accordingly. Because if I store water and then the evaporation will suck all the water, then I have nothing for the irrigation purposes, for the power generation, I have nothing there. So that's how we use this kind of data for the urban infrastructure. Okay, so I will get back to this class. This is a classwork that you will select again the 2 grid locations anywhere in the United States. But for the better contrast, let us see if you want to select one grid location, Boston Steel, right? Urban. Then you can think of go a bit away from that location and choose somewhere in the Massachusetts only, the non-urban area. So you will have better contrast. You can write, will give a better explanation about how it's changing, urban and urban. It's not like you will select one grid point here, and another grid point you will select here. then there's no point because there's a huge spatial variation across the United States. So the area is very large for the United States. So it's better if you can, let's say in Boston, or here, Massachusetts. So try to, if somebody wants to select the points in Massachusetts, try to select close. But make sure that there's a contrast with the urban and non-urban. Okay, any doubts so far? No doubt? Oh. So please open your Husky Google account. So you will have a Google Colab there. You are supposed to open the Google Colab. Then we will do all this analysis. We will run all the code for this analysis. Then I will tell you what you are supposed to do for the home classwork, and then what will you expect in your assignment. So assignment is going to have around 10% of your total mark. So I will explain all those details to you. I will also so this is Northeastern Husky Google Drive. Everyone has it? So then we have one folder there that's name is Climate Dialogue 2024. Is it there? No, just reach this point. Right here. Kindly open your Google Husky Google account. Google Drive.
I will share you
No,
the drive.